Okay, in example one, what you need to do is sketch the function f of x. So it's a piecewise function with three different pieces. Follow the steps that I showed you on the previous slides. After you've done that, you can use your graph or you can use the formula if you find that easier to find the value of f of -1 over 10, f of 0, and f of 3 over 2. So pause the video, take a minute to do this example, and then press play to watch the solution. Okay, let's go for the solution. So let's sketch the graph first. Let's draw a Cartesian plane here. And what we're going to do is we're going to identify where our domain breaks. So we have x is less than 0. So I know there's a break at x is less than 0. We have x is equal to 0, and then we have x is greater than 0. So I can see from the different portions of the piecewise function that we clearly have a break at x is equal to 0. So let's just make a dotted line at x is equal to 0 to see that we have a break there. Okay, so that's x is equal to 0. Now let's plot this function. So when x is less than 0, we are going to plot the function x squared. So if we had to do that, we are going to look at x is less than 0. We're looking toward the left of x is equal to 0, toward the left of that light blue line. We would have to plot this function here. Okay, one side of a parabola, because remember the full parabola x squared looks like this, but I'm only interested when x is less than 0 toward the left or on the left of that light blue dashed line. So we're looking at this portion here. So this is what we are going to end up with. And notice we have x is less than 0. It is not x is less than or equal to 0. So we are going to have an open dot for now at 0. And we will label that 0 and 0. How I get this open dot at 0 is insert x is equal to 0 in x squared. You'll get a y value of 0. So there's your x value, the y value, and we put an open dot at 0, 0, the origin basically. Then let's look at the next portion of the piecewise function. So when x is equal to 0, now this is something slightly different. We don't have less than, or equal to, greater than or equal to. We just have the equal to sign. So this is going to be a single point. So when x is equal to 0, the y value is going to be x plus 8. So when x is equal to 0, the y value is equal to x plus 8. How do you work that out? Well, x is equal to 0, so sub in 0 into the y value. We'll have 0 plus 8. That's going to yield plus 8. So plus 8 should be somewhere here. And notice we have equality. X is equal to 0, hence why I have a closed dot here. And that point is going to be 0 and positive 8. And that's how we deal with an equality. Just a straight equality, that is going to be a single point on an absolute value graph. Let's deal with the last part of this graph. So when x is greater than 0, meaning I'm looking at the right side, toward the right of this light blue dashed line, we are going to plot the function negative x cubed plus 4. Okay, so this may be slightly tricky if you don't know how to draw the cubic function, but let's start from basic principles. So I'm just going to have a different Cartesian plane here and show you how to draw this x cubed plus 4. What you need to understand is that, or what you need to know, is that the x cubed function looks like this. Okay, so I encourage you to learn or memorize how that looks. And it's got an x-intercept and y-intercept of 0 and 0. Okay, so that's x cubed. Now we have a negative x cubed term. So what we're going to do to this function here is we're going to put a negative in front of it. If I put a negative in front of the entire function, I'm reflecting it on the x-axis because I'm basically changing the sign of y. Let me explain that more clearly. I have y is equal to x cubed. I need y is equal to negative x cubed. How can I get that? Let's just put a negative sign in front of the y, sorry. And then if I have to take the negative over onto the other side, we'll get y is equal to negative x cubed. What I essentially did is I put a negative sign in front of the y, meaning I have to reflect along the x-axis. So this negative x cubed graph is going to look like so. Let's draw it a bit better than that. There we go. Okay, still having a y-intercept and x-intercept of 0 and 0. And then we have a +4 term. So that's just a vertical shift. We need to shift it 4 units upward. It's going to look like so. And now it's going to have a y-intercept of 0 and 4. Y-intercept of +4. Okay, but we want to draw this function here whenever we are on the right side of x is equal to 0. That's the line that I was considering. So we are essentially going to draw that portion there. So it's going to have a y-intercept of +4. +4 is somewhere here. Well, it's halfway between 0 and 8, so it's there halfway between. And notice that the function here just curves downward like that, so it looks like so, and it goes on forever. And notice that here I have an open dot because its x is greater than 0, not x is greater than or equal to 0. So there's no equality at that specific point. So it's an open dot for this portion of the function, and we'll label that open dot 0 and +4. To get this point here, this x-intercept, you need a calculator. If you are using a calculator, you'll find that that point is going to be 1.587 and 0 for the y value. How did I get 1.587? Well, it's super easy. You just have to equate negative x cubed plus 4 to 0 and solve for x. You'll have to be solving for x cubed is equal to +4. X is equal to the cube root of 4. You find the cube root of 4 on a calculator, you should get 1.587. And that is how you plot this piecewise function. Before we move on to the next example, we just need to finish up with this question. So we need to identify those y values. So let's just make some space here. Okay, firstly, we need to find f of -1/10. So how you would do this with a piecewise function is look at your x input value. Your x input value is -1/10. Ask yourself, is -1/10, or if you're more comfortable using decimals, -1/10 is -0.1. Is that an x value that's less than 0, equal to 0, greater than 0? Clearly, it's a negative value, so it has to be less than 0. So your y value is going to be, it's going to follow the y is equal to x squared part of this piecewise function. Okay, so we are going to have to take the x value, which is -1/10, or -0.1, and square it. We are following the first part of this piecewise function. So if you take -1/10 and square it, you're going to get 1/100, because 1 squared is 1, 10 squared is 100, and a negative squared obviously becomes a positive. That negative sign is going to disappear. So this is going to be 1/100, or if you're more comfortable with decimals, 0.01. And that's how you handle the first one. Then we'll deal with f of 0. So we have f of 0. Then all you need to ask yourself is, what's your x value, or your x input value? Well, it's 0. Is 0 less than 0, equal to 0, greater than 0? Well, your x input value is 0. So it's clearly equal to 0. We have to follow this function here, x plus 8. So your output is going to be x plus 8, but your input value is 0, so we have 0 plus 8, and that's just equal to 8. And it makes sense because we have that point plotted on the graph. Okay, let's deal with the last one. We have f of 3/2. So how would we handle this? Well, the same steps. Our x input value is 3/2. Ask yourself, is that less than 0? Is it a value that's equal to 0? Or is it a value that is greater than 0? Well, clearly 3/2, or 1.5 in decimals, is greater than 0. So we are following this function here at the bottom, the third part of the piecewise function. So this is equal to negative our input value, which is going to be 3/2 because we have a negative x cubed. So x value was 3/2, cube it, and then we are going to add 4. Let's work this out. So we have a negative sign, 3 cubed on the top, that's going to be 27, and then 2 cubed is going to be 8, and then plus 4. Okay, take a minute to work this out. We are going to have negative 27 over 8. 4 expressed with a LCD of 8 is going to be plus 32 over 8. So then we have negative 27 plus positive 32. That's going to be 5 over 8. And there's your final answer. Okay, 5 over 8 for f of 3 over 2. And that's how we handle example 1. Let's move on to example 2. So in this example, we need to sketch the function of f, and f is a piecewise function that has two portions. And then same thing, we need to find f of 3, f of 0, and f of negative 1. So if we look at this piecewise function, let's look at the first part. It's equal to x squared minus 5x when x is not equal to 3. So this is a bit different from what we've seen in the previous examples. Now we have something that is not equal to 3. But let's just take a minute and think about what not equal to 3 actually means. If I had to say that x is not equal to 3, how else could we represent that using inequalities? Well, if x is not equal to 3, then x could be less than 3, or x could be greater than 3. Okay, if it's not equal to 3, it can be any number that is less than 3 or greater than 3. If I tell you, pick a number that is not equal to 3, you could pick a number such as 2, such as 1, such as negative 10. You could even pick 2.99. Any number that you pick that is less than 3 would be a valid answer to my question or my statement of saying, pick a number that is less or not equal to 3. So you could pick a number that's less than 3, or you could pick numbers like 5, 7. You could even pick 3.01. In that case, you'd be picking numbers that are greater than 3. But in any event, in both cases, you would still not pick 3. So you can say x is not equal to 3, or x is not equal to 3 can be written as x is less than 3, or x is greater than 3. Just take a moment and think why we wouldn't say x is less than or equal to 3. Well, the statement here is considering equality. It's made up of two things, x is less than 3 and x is equal to 3. And we clearly said that x cannot be equal to 3. So this statement shouldn't be there. That's why we cannot say less than or equal to, and for the same reason why we can't say greater than or equal to. So this is one way to break it up. So now that we know x is not equal to 3 can be written as less than 3 and greater than 3, we can rewrite that piecewise function f of x as this. Okay, so we'll open a big curly bracket. We'll have x squared minus 5x whenever x is less than 3. We'll have 2 whenever x is equal to 3. And we'll have the exact same function, x squared minus 5x whenever x is greater than 3. So this piecewise function here, this piecewise function where we have a not equal to sign can be written like this. And that's one way of approaching it. And from here, you can follow the steps and plot the function. Another way, instead of writing all of this out, is to just plot the function directly. And I think this way is much easier. Okay, so in both cases, you'll get the same sketch, but let's go through it. So we're going to have our Cartesian point here. And what I'm going to do is I'm going to sketch this function x squared minus 5x. Okay, so if I had to sketch that function, take your time, get its factors, get its turning points. If you have to work that out, it will look like so. Okay, that's not the greatest parabola. Let's try sketching it again. So it will have an x-intercept at 0 and 0, and it will look like that. Okay, we can label these points here. It's x-intercepts. Those are going to be 0 and 0 for this point here. And this is going to be, let's check, it will be 5 and 0. Okay, and then it's going to have a turning point at, let's see, if you had to work out the turning point, it would be 2.5, or 5 over 2, and minus 6. 0.25. Okay, that's the turning point. But there's one important thing that we are missing. Okay, this function, we are supposed to draw the x squared minus 5x whenever x is not equal to 3. So what we've done is we've drawn it for x is an element of real numbers. So to rectify this and satisfy that condition where x is not equal to 3, what we need to do is go to the value of 3. So x is equal to 3 should lie to the right of the turning point because the turning point is 2.5. So that should be somewhere here. X is equal to 3. And we are going to put an open dot at x is equal to 3. And we'll label that because we have to draw this function wherever x is not equal to 3. So that means at the value of x is equal to 3, we need to have an open dot, okay, meaning it's not including x is equal to 3. So we'll just label that point as well. That's going to be 3 and -6. There we go. And that's how we plot the first part of this piecewise function. And the last part is super easy. Whenever x is equal to 3, the y value is 2. So here's x is equal to 3, that's that line here. We will plot a y value of 2, and 2 is somewhere here. So let's just plot that without the dashed line. It will look like so. There we go. It will just be a single point out in this space here. So that's going to be 3 and +2. And then we need to find out these values, f of 3, f of 0, and f of -1. Let's work that out. So f of 3, clearly, we have an x input of 3. The value is 3. Is the value not equal to 3? No, it's not. We have x is equal to 3. So we are dealing with the second part of this function. So the y value, f of 3, is going to be 2. So f of 3 is 2. Then we need to find out what is f of 0. So we have an x value of 0. Is that value not equal to 3? Yes, 0 is clearly not equal to 3. So we are dealing with the first part of this function, x squared minus 5x. And if you have to substitute 0 into x squared minus 5x, you will get a value of 0 or a y value of 0. And then if you have to look at the next one, which is -1. So the x value is -1. -1 is clearly not equal to 3. So we are dealing again with the first part of this piecewise function. So what we have to do is substitute -1 into x squared minus 5x and calculate what your y value will be. If you do that, you'll get -1 squared, which is +1, minus 5 times -1. So that is going to give you 1 plus 5. A -5 times a -1 becomes +5. So that is going to give you a y value of 6. Okay, so it's 2, 0, and 6. And that's example 2 completed.